The reddish star on the shoulder of Orion that you can walk outside and see tonight left that light on its way to you somewhere between 5 and 7 centuries ago. Think about who was alive when it departed. The photons landing in your eye right now began their crossing while medieval Europe was still standing, and they have been falling towards you, unbroken, ever since. Which means the star you're looking at is not the star as it is. It's a portrait of how it looked before your country existed. And here's the thing that should make the back of your neck prickle. Betelgeuse is a dying star, close enough to the end that in a very literal sense we cannot be certain it is still there. The light says it lived. The light is old. For a few months in the winter of 2019 and 2020, that uncertainty stopped being a philosophical curiosity and became a genuine heart-in-throat question for some of the best astronomers alive. Because Betelgeuse started going out, not flickering, fading, dropping, night after night, dimmer than anyone had recorded it in well over 100 years of watching. And a red supergiant that suddenly darkens is doing exactly what theory says a star might do in the final act before it detonates. So the whispered question moved through observatories and across the internet all at once. Are we about to watch a star die, live, for the first time in 400 years? The title of this video says Betelgeuse began collapsing. I'm going to be honest with you from the first minute, because the real story is better than the clickbait version. It did not collapse. It did not explode. But what actually happened in that winter, and what we've pulled out of the glare of that star in the years since, right up through a discovery announced from a telescope in Hawaii in the last couple of years, genuinely changed how astronomers understand the way these giants behave in the run-up to their deaths. By the end of this, you'll know what really dimmed Betelgeuse, why that answer rewrote a chapter of a stellar science, and the thing that was hiding in plain sight beside it the entire time. Something nobody managed to see until they knew the exact night to look. Keep that in mind, the hidden thing. We'll get there, and it's going to reframe everything that came before it. Let's start with the monster itself, because you cannot understand the fear without understanding the scale. Betelgeuse, Alpha Orionis, the star marking the hunter's shoulder, is a red supergiant, and the word super is doing a lot of quiet work there. Our sun is a comfortable ordinary yellow star about 865,000 miles across. Betelgeuse is something else entirely. If you plucked our sun out of the center of the solar system and dropped Betelgeuse in its place, its surface would swallow Mercury, Venus, the Earth, Mars, the entire inner solar system, and keep going, its outer layers, reaching out toward the orbit of Jupiter. Here's how to picture it. Everything you think of as the neighborhood, every rocky world, including the one under your feet, would simply be inside the star. It carries somewhere around 15 to 20 times the mass of the sun packed into that vast, bloated body. And it is not a smooth ball. Its surface roils and boils in colossal, convective cells, bubbles of hot plasma each large enough to span a good fraction of the inner solar system, rising and bursting like the surface of a pot left too long on the heat. In 1995, Betelgeuse became the very first star beyond our own sun to have its actual surface resolved into an image by the Hubble Space Telescope. Not a point of light, but a visible, modeled disk. And it is young, almost obscenely young. Our sun is 4.5 billion years old and barely middle-aged. Betelgeuse is something like 8 to 10 million years old, a few thousandths of the sun's age, and it is already dying. That's the brutal bargain of enormous stars. The more mass you have, the more ferociously you burn, and the faster you race toward the end. Betelgeuse has lived fast, and it is nearly out of road. It also, being a supergiant, has a naturally unsteady brightness. For as long as we've kept careful, they'd relied on it for over a century, which is exactly why, in late 2019, they knew immediately that something was wrong, because what the star did next did not fit that gentle rhythm at all. If a star this immense, this close to the edge, boiling and shedding and racing toward oblivion is already pulling you in, do yourself a favor and subscribe. Because the next part is where the whole world started watching, and where the real mystery begins. In October of 2019, Betelgeuse began to fade. That by itself was normal. The star dims on its cycle. But it didn't stop where it should have. It kept dropping, through November, through December, into January. By the deepest point, in the window between January 27th and February 13th of 2020, Betelgeuse had fallen to roughly 40% of its usual brightness. The faintest it had appeared in well over a century of documented observation. And this wasn't some subtle shift only a spectrograph could catch. You could see it with your own eyes. Anyone who knew the winter sky could walk outside, look up at Orion, and notice that the great red shoulder had visibly, unmistakably dulled. A star that human beings have used as a fixed point for navigation and myth for thousands of years, painted, some suspect, on cave walls recorded in Chinese and Mediterranean antiquity, was dimming in real time in front of everyone. The astronomy world lit up, and not only with excitement, with a very specific dread. Because there's a reason a dimming red supergiant is alarming. And to feel it, you need to understand how a star like this actually dies. Every star is a standoff. Gravity is relentlessly trying to crush it inward, and the only thing holding the line is the outward pressure of nuclear fusion in the core, converting light elements into heavier ones and releasing energy. For most of a star's life, that fuel is hydrogen fusing into helium. But a massive star like Betelgeuse doesn't stop there. When it runs low on hydrogen, it starts fusing helium into carbon. Then carbon into neon and oxygen. Then heavier still towards silicon, and each rung up this ladder burns faster and lasts shorter than the one before. The star frantically feeds. And when they laid the images side by side and published them in the journal Nature in 2021, the story was written right there on the star's face. Betelgeuse hadn't dimmed evenly, like a bulb on a dimmer switch. The lower portion of the star, the southern region of its disk, had gone dark, shadowed, as though a veil had been drawn across the bottom of it. The star was being hidden, partially eclipsed, but not by another star, by something it had made itself. And that is where the deepest piece of the puzzle fell into place, in work led by Andrea Dupree at the Center for Astrophysics, Harvard and Smithsonian, using among other things the Hubble Space Telescope to watch the star's outer atmosphere, piece the timeline together, and here is what appears to have happened. Early in 2019, deep beneath the surface, one of those colossal convective cells drove a violent shock upward, a burp of the star's own guts, but on a scale that defies comprehension. It blasted an enormous cloud of dense gas clean off the surface of Betelgeuse and out into the star's vast extended atmosphere. Astronomers call it a surface mass ejection, and while our own sun does small versions of this all the time, what Betelgeuse did was monstrous by comparison, flinging out a cloud of material more than 100 million miles across, carrying away a mass comparable to what the star normally sheds in an entire year of its stellar wind in one event. Over the following 11 months, that ejected gas drifted outward, and as it moved away from the star's heat, it cooled. And cooling gas of this composition does something specific. It condenses into dust, fine, dark grains of it, and that freshly minted dust cloud drifted into the line of sight between Betelgeuse and Earth and threw its shadow across the lower half of the star. The Great Dimming, in other words, was not a star beginning to die. It was a star coughing up a piece of itself and then hiding for a while behind the smoke. By April and May of 2020, the star had brightened back to normal as the dust dispersed. The panic faded with it. But here is why this near miss genuinely mattered and why it belongs in any honest account of how giant stars die. For the first time, astronomers had watched, resolved on the disk of the star in real time across the whole spectrum of light, a red supergiant violently, episodically hurl off a huge chunk of its own mass. We had always known these stars bleed material into space through a steady wind. What Betelgeuse showed us is that they can also do it in sudden, dramatic, unpredictable heaves, and that a single one of these events can shed as much as a year of the ordinary wind. That reshapes how we think about the entire final stretch of a massive star's life, how much mass it loses and when, what clouds of material it wraps itself in, and therefore what environment the eventual supernova will explode into. Betelgeuse didn't rewrite stellar death by dying. It rewrote it by letting us watch, up close, the kind of convulsion these stars go through on the long approach to the end, and by teaching us how to tell the difference between a surface tantrum and a genuine death rattle. That distinction is going to matter enormously the next time a supergiant anywhere starts behaving strangely. Let me pause here for one beat, because we've reached the turn in the story. If you're finding this as gripping as I do, a quick like genuinely helps push it to other people who'd want it, and I'm curious where you landed. When you first heard Betelgeuse was dimming, did you secretly hope it was about to explode? Be honest. Now, the twist I promised you, because the story of Betelgeuse had a second mystery running underneath the first one the whole time, and it took until December of 2024 to catch it. For over a century, careful observers had noticed that Betelgeuse's brightness didn't just follow that 400-day pulse. Layered on top of it was a second, much slower rhythm. A long, gentle rise and fall repeating roughly every 5.5 to 6 years. This long secondary period showed up in many red supergiants, and nobody could firmly say what caused it. And in 2023, this obscure detail suddenly became explosive because a team led by Hideyuki Sayo at Tohoku University in Japan analyzed Betelgeuse's pulsations and argued something startling, that the star was already burning carbon in its core, the late penultimate stage, and could therefore be far closer to detonation than anyone assumed, possibly within centuries, conceivably even less. For a moment, the supernova panic reignited. But other astronomers, notably Meredith Joyce and Laszlo Molnar at the Konkoly Observatory in Hungary, pushed back firmly. They argued the star was still comfortably in its helium-burning phase, with something on the order of 100,000 years left, And, crucially, that the long, slow rhythm Scio's team leaned on wasn't a signal from deep inside a dying core at all. It was something else, something orbiting the star. The idea of a hidden companion to Betelgeuse had floated around for decades, but the giant's ferocious glare had defeated every attempt to see one. Then the models made a testable prediction. If a companion existed on the orbit that would explain that 6-year rhythm, it should swing out to its greatest visible separation from Betelgeuse around December of 2024, and then vanish behind the giant's glow for years afterward. That's a narrow window. Steve Howell, a senior scientist at NASA's Ames Research Center, went for it, using the Alipix speckle imager on the 8-meter Gemini North Telescope in Hawaii, an instrument that fires off thousands of ultrafast snapshots to freeze out the blurring of Earth's atmosphere. He took one set of images back in February 2020, when the predicted companion should have been hidden directly behind Betelgeuse, and found nothing, exactly as expected. Then he took a second set on December 9th, 2024, right at the predicted moment of greatest separation. And there it was, a faint point of light tucked right up against the blazing edge of the supergiant. Betelgeuse has a companion, a hidden second star, whipping around it on a roughly 6-year orbit, its subtle gravitational tug the real source of that century-old slow rhythm in the brightness, the very signal that had been misread as a possible sign of imminent death. Astronomers had nicknamed the still theoretical object Betel Buddy, and once it was found, they gave it a real name, Siwarha, meaning her bracelet, because the name Betelgeuse traces back to Arabic for the hand of the giant, and this little star circles that hand like a bracelet. And little is relative. Siwarha appears to be a hot, young star of somewhere around 1.5 to 2 times the Sun's mass, so young it hasn't fully settled into stable adulthood as a star yet. Picture that pairing. An ancient, bloated giant in its death throes, and a small, still youthful companion looping around it, so close that it is skimming through the giant's own distended outer atmosphere. And that closeness may be a death sentence for the smaller star. Because Siwarha orbits within the tenuous outer reaches of Betelgeuse itself, it's constantly plowing through that material, and the drag is expected to steal its orbital energy little by little, tightening the loop, pulling it inexorably inward. The prediction is that within a few thousand years, this companion may spiral all the way in and be swallowed whole by the dying giant it's been circling. A small star, orbiting a doomed one, itself doomed, and we found it, quite literally, in the last light of the giant, in a single observation timed to the 1 week it would be visible before hiding again until 2027. So where does that leave Betelgeuse? And us? Honestly, in a place of magnificent uncertainty, which is the truest thing I can tell you. The mainstream estimate is that Betelgeuse will explode sometime in the next 100,000 years or so, which on a human scale means it is overwhelmingly likely that neither you nor anyone you'll ever meet will see it happen. And yet nobody can rule out the shorter timelines, and there's a genuine, unresolved scientific debate about exactly which fuel the core is burning right now. A debate we can't settle because no telescope can see into the heart of a star. We read the tremors on its surface and we argue about what they mean. And layered on top of all of it is that light travel paradox from the very beginning. The Betelgeuse we see is the Betelgeuse of 5 to 7 centuries ago. It is entirely possible, improbable, but possible, that the star has already exploded, that the flash is already racing across the light years, and that, on some ordinary future night, without any warning, the shoulder of Orion will begin to blaze. When it does finally go, it will be the most spectacular thing in the sky. A star that close, exploding, would flare up to rival the brightness of a half-moon, bright enough to see in broad daylight, bright enough to cast shadows at night. And it would hang there, slowly fading, for weeks or months before dimming away forever, taking Orion's shoulder with it and reshaping a constellation humans have recognized for all of recorded history. And before a single photon of that brilliance arrived, we would already know. The collapse of the core releases a flood of ghostly particles called neutrinos that pour out of the star and cross space slightly ahead of the light, and detectors buried deep underground here on Earth, like Super Kamiokande in Japan, are watching for exactly that burst. It would give us a few hours' warning, the first news of a death that happened centuries ago finally reaching us, and you'd feel nothing. Roughly 100 trillion of those neutrinos would sail harmlessly through your body, because, for all its violence, Betelgeuse is far too distant to hurt us, comfortably beyond the range where a supernova poses any threat to Earth. We would get the greatest light show in human history and not a scratch. Step back and look at what this one star has done to us. We watched it fade and braced ourselves for its death, and it was only clearing its throat. We chased the mystery of its dimming and learned for the first time how a giant sheds its flesh in the years before it dies. We argued over a slow flicker in its light that we thought might be a countdown, and discovered instead a whole hidden star, circling and doomed, betrayed by the very rhythm we'd misread. And after all of it, we still cannot say for certain whether the red point of light on Orion's shoulder tonight is a living star or the centuries-old ghost of one. That's not a failure. That's what it actually feels like to stand at the edge of what we know, staring up at something enormous and old and still keeping secrets. If you rode this all the way to the end, you're exactly the kind of person this channel is built for. So subscribe and turn on notifications, because when the verdict comes in on that companion's orbit, or the next time Betelgeuse does something it isn't supposed to, we'll be here to break it down first. And I want to hear from you. Which part genuinely got you? The surface mass ejection that flung a 100 million mile cloud of the star into space, the winter the world thought it was watching a supernova begin, the hidden companion star we only caught in a single week of December, or the quiet, unsettling fact that Betelgeuse might already be gone? Tell me in the comments. And the next clear night, when you're outside, look up at Orion's shoulder and find that reddish star, because you're not just looking at a light. You're looking at old news from a dying giant. And one of these nights, for someone, the rest of the story is finally going to arrive.